Hey there, welcome back. Man, it's awesome. It's awesome to have you. In Quest 1, you did something pretty cool. You tamed chance itself. You built that reusable dice engine, a little system that could roll out endless possibilities. But here's the thing, pure randomness by itself doesn't really feel like a game. It's missing that spark of tension, the oh no, what if I fail feeling. Games need resistance. They need gates. They need something standing in between the player and victory, daring them to push through. So today we're building exactly that. We're constructing a lock. Welcome to the ShadowVault. Alright, take a breath, grab your keyboard, and let's get into it together. First, we're going to go ahead and create a brand new folder, call it Code Quest 2. Inside that folder, make another folder called SRC. Then, right inside SRC, create two fresh files, main.py and shadow_vault.py. Pause for a good second and look at what you're doing. See how we're not stuffing everything into one giant file? That's a big deal. That's how real scalable software gets written. By giving each piece its own home. Each file has a clear job. Each module has purpose. Now open up shadow_vault.py. Import random at the top. Because every good vault needs its own secret, right? We're going to create class ShadowVault. Think of that class as a blueprint. Not the actual thing, but the instructions for how to build it. This ShadowVault is going to be an object that holds its own state. Inside the class, we start the initializer, the constructor, right this, def__int__, in parentheses self, comma, min code equals 1, max code equals 10, max attempts equals 5. See those default values? They make our system flexible. You can create a super easy vault or crank it up to a nightmare mode later without rewriting everything. Now store those values on self. Self.minCode equals minCode, self.maxCode equals maxCode, self.maxAttempts equals maxAttempts. And then the magic moment, generate the secret. Self.secret_code equals random.randint. In the parentheses, we're going to have self.minCode and self.maxCode. Boom! Every time you make a new ShadowVault, it gets its very own hidden number. That's encapsulation in action. The secret belongs to the vault and nobody else can just reach in and grab it. Feels mysterious already, doesn't it? Now, let's give our vault a way to judge guesses. Add this method, def check_guess. In the parentheses, we're going to have self and guess. Inside it, we just compare if guess is equal to secret, return correct. If guess is less than secret, return low, else, otherwise, return high. Notice something important. We're not printing anything here. We're only returning information. That's on purpose. We keep the logic clean and separate. It makes the code reusable later. Alright, now the real heart of the puzzle, the play method. So we're going to define play with self in the parentheses. This is where the tension lives. Start by printing a nice welcome message that tells the player the range. I'm thinking of a number between X and Y, and how many attempts they get. Make it dramatic. You're the storyteller here. Then set attempts equal to 0. Now the loop. We're going to have while attempts is less than self.maxAttempts. Inside the loop, ask for an input, but wrap it in a try and accept. So, if they type red instead of a number, catch that value error, give them a gentle, hey, that needs to be a number, buddy, and keep going. This is called input validation, and it's one of those quiet superpowers that separates polished games from frustrating ones. Never trust a player to be perfect. They're humans just like us. Wink. Once you have a valid guess, bump the attempts counter, then call self.checkGuess, guess inside the parentheses, and store what it returns. If it says correct, celebrate, print something like awesome, the vault clicks open, you did it. then return true. If it's low or high, tell them kindly and show them how many tries they have left. Let the pressure build. That little countdown, that's pure game design magic. If the loop ends without success, time for the sad trombone. Womp womp. Print a failure message. Reveal the secret because learning is part of the fun, and then return false. Returning true or false is intentional. Later on, other parts of your game can react to whether the player won or lost. That's how you start connecting systems together. Woo! Let's take a sip of water if you need it. Ha! That was a solid chunk of code. Now flip over to main.py. At the top, we're gonna from ShadowVault, import ShadowVault. Then in your main function, hit them with the dramatic title, something like The ShadowVault awaits! Create an instance. Vault equals ShadowVault. 1, 10, 5. From 1 to 10 and 5 attempts. You can tweak those numbers anytime to change the whole mood of the game. Then simply add unlocks equals vault.play. After the game ends, branch on that success value. If true, give them a victory fanfare. If false, maybe a little ominous message about the vault staying sealed forever. I don't know. Even if it's just text right now, you're building the skeleton for real consequences later. At the very bottom, don't forget the professional entry point. All right, let me try again. Professional entry points. Beautiful. Now pause with me for a second and look at what you've built. You've created a real class with its own private state. You've used constructor parameters with sensible defaults. You added randomized secrets. You handled bad input gracefully with try and accept. You controlled the whole experience with a clean loop and attempt limits. You returned Boolean values so other code could listen. And you kept logic and display nicely separated. This isn't beginner-friendly scripting anymore. This is proper object-oriented design. You're writing code that feels alive. It's alive! But here's the part that actually gives me chills. Oh, you didn't just write code. You built tension. There's a secret out there in the dark. A deep, dark secret deep down inside that no one will ever know. The player doesn't know it. They only have a handful of chances. Every guess brings them closer to victory or to running out of time. Clear feedback, rising pressure, that delicious one more try feeling. Oh yeah, just one more. Come on, one more. I know I can win big on this one. Come on, hit me. That's game design. They're right on top of programming. Go ahead and run it a few times. Watch how every volt feels different. Change the range 1 to 100 and feel the difficulty spike. Drop the attempts to 3 and watch the sweat form. You're not just coding features, you're tuning emotion. Quest 2 is officially complete. And in the next quest, we're giving the player something worth fighting for. An identity, an inventory, a reason to care. The enchanted inventory awaits. I'll see you there. Keep creating. You're doing an amazing job.